That's another lesson. Now on exceptions. With a different music style.
Santa's elves are building toys, a flurry of festive cheer. But the toy bewilder class throws an error, filling Santa with fear. An illegal argument exception, a wrong toy material's name. An unchecked exception appears, disrupting Santa's game. Oh, try catch blocks of Christmas might to handle those exceptions shining in the light. Some we must catch, others we may ignore, protecting Santa's code forevermore.
Okay, what did we hear now? There is a problem in Santa's toy building. Let's have a look at this toy builder, how it's implemented. We have the toy builder here. That's the class toy builder. It has a build toys method. And now let's see what Santa's elves are doing to run the toy builder. Here's our main method. And we're going to have a few materials to build toys with, because that's actually what the build toy requires, material. And then we're going to run this for plastic toys, coal toys, wooden toys, wool, and metal. So let's see what happens when we run this. Well, we built a plastic toy, but then something bad happened. There was an exception, an illegal argument exception, when we gave the coal. Because what happens here, the toy builder checks for the material coal and rejects it, because coal is only for the naughty children and it's not going to build toys from that. So it throws an illegal argument exception. Now, throwing an illegal argument exception in the toy builder will immediately stop the flow of the program here. See, this line, toy built with coal, is no longer executed. And then it even didn't continue with this loop. It didn't try to build the next toy with wood or wool or metal. It completely stops the execution. Why is that? Because we didn't catch the exception. So there are some exceptions. This one is one of the unchecked exceptions that we are not necessarily required to say how we're going to handle them, because they could happen at runtime. They could always happen, so we don't necessarily have to always catch them. But the way to actually treat this now is if around this line of the toy builder build toy with the material, we put a try catch block. So we're going to say try building this toy. If you catch an illegal argument exception, you're going to write a special message. So you're going to do some handling of that exception, and then you just continue. So let's see whether this execution works better. Let's try again. So it said again, build toy with plastic, right? So here a regular execution worked fine. And then it says coal didn't build a toy. So throwing the exception here will again disrupt the execution of this method immediately where the exception was thrown. But when it propagates up here, it's actually caught. And then we're going to say material did not build a toy. So coal did not build a toy. And then the for loop is not impacted because now we caught the exception. We handled it and the for loop can continue. That's great. So try catch are ways to try things that might throw exceptions and then catch those exceptions to handle them. Let's see what else might happen.
The reindeer harness checker ensures a safe takeoff, but a null value for Prancer gives the elves a little shake. A null pointer exception, unchecked and unforeseen. Santa's quick to fix the issue so his sleigh can be keen. Oh, try catch blocks of Christmas might to handle those exceptions shining in the light. Some we must catch, others we may ignore, protecting Santa's code forevermore.
Okay, so here a really important thing is that it says some we must catch, others we may ignore. Because what we saw before, we had an unchecked exception, and this means we can ignore it, the illegal argument exception. We didn't have to write this try catch. The code here was compiling. Now, the null pointer exception that we get in the reindeer harness checker, that's another unchecked exception. So let's see, we have our reindeer harness checker. The reindeer harness checker can check the harness of a reindeer. So let's see if we can take off. Let's run this. We're going to get a reindeer harness checker, check the harness, and then we say ready for takeoff. Oh no, that didn't work. There was a null pointer exception. Where did this happen? So that's where stack traces come in. When we see the exception come up, we also see this stack trace here. It says, well, in the main method of takeoff line 28, we called check harness. And then inside check harness, in line 7, something bad happened. That was throwing the null pointer exception. So let's see, in check harness, line 7, we said reindeer get name, but our reindeer was null. Okay, so now how do we fix this? Do we need to do again try catch? Here, try catch might not really be the best option, right? Because we can't really recover from checking harness with just try catch. Maybe what we should do is actually we should make sure there's a reindeer, and we don't need to try catch. We can just say, well, let's give a reindeer to the checker of the harness, and then let's see if it works. So now run. Yeah, this time no null pointer exception is thrown. So sometimes the null pointer exceptions, we don't necessarily have to catch them. We can just fix the code so that they won't appear. Because now there's always a reindeer, well, here in this case Dasher, and then we're ready for takeoff. Let's continue.
Gift wrapping machine packs presents with the bow, but a Philo not found exception makes the wrapping process slow. The file with wrapping paper patterns can't be found, it's true. A checked exception, Santa's code must see it through. Oh, try catch blocks of Christmas night to handle those exceptions shining in the light. Some we must catch, others we may ignore, protecting Santa's code forevermore.
Okay, so now we finally have a different kind of exceptions, a checked exception. Now let's see what that means. We have the gift wrapping machine. The gift wrapping machine has wrapped gifts. It tries to load a pattern from a file, and then if the file pattern doesn't exist, it throws a file not found exception. Now, let's do it before as we did with null pointer exceptions and so on. Let's not put this strange declaration here. It says, well, there's a problem here. Now, this one is a checked exception. Those are exceptions that we have to declare. We have to say we need to take care of them. So here the complaint is, well, let's see the complaint. Let's see. Well, here, unhandled exception of type file not found exception. So it says, well, this is a kind of exception you need to handle. So, well, we can fix it by saying, we're just going to say that we're going to throw this kind of exception. Good. But now the code that wants to execute wrap gifts also has to continue throwing this exception or handle it, right? So let's see, if it wouldn't do anything, if it just calls it, it tells it now, oh, there's an unhandled exception because this method told us it's going to throw a file not found exception. And those are not unchecked exceptions like the null pointer or the legal argument. We have to actually either handle or throw this exception. Otherwise, the code won't even compile. So let's see, if we run this and we're going to say throw this exception, then we're just going to find exactly what happened before. We're calling wrap gifts in the main method. Wrap gifts in line 11 throws this exception, and then we're going to terminate the whole execution basically right here. There's no using wrapping pattern from file, and the execution stops. So that's the same as unhandled, unchecked exceptions. But now we have to declare what we're going to do with them, and we're going to say, well, we're not handling them. We can just throw them. An alternative, which we should always consider, is actually we should catch them. Maybe we should try to handle them. So this is here again, try catch, same as for the null pointer exception, same as for the illegal argument exception. And then we don't have to write this throws found not found exception, right? We shouldn't, because we shouldn't say it does when here we are handling those kind of exceptions and terminating with no wrapping paper patterns found, right? So this way we might also throw exceptions, and that only is necessary for those exceptions where they are called the checked exceptions. So like file not found, or some other examples, but not the unchecked ones, which are maybe so common that we don't need to handle them. But these ones we have to either handle with a try catch, and then we don't declare that we want to throw them further, or we simply say, well, we might throw this kind of exception, so somebody else please take care of this. Okay, so gift wrapping saved. Let's continue.
From throwable descends the family tree, exceptions of every degree. Error types like out of memory error, Santa must avoid, it's clear. While checked exceptions must be caught or declared with care. Unchecked exceptions sometimes we can leave to thin air. Oh, try catch blocks of Christmas might to handle those exceptions shining in the light. Some we must catch, others we may ignore, protecting Santa's code forevermore. The Christmas Carolers class plays music in the night. The finely block ensures the music's always right. Closing audio streams, turning off the festive lights. No matter the exceptions, everything's just bright.
Okay, so that's a new thing, the finally block. What happened here is that sometimes we have some, well, cleaning up to do, and that's what the finally block will do. So let's say here's our Christmas carolers. They sing carols, which they load maybe from a file, and let's say in the beginning we turn on the audio system. Then there's a file writer, which writes down which carols were sung, and then we're reading the carol file, which could lead to the read string. This could lead to some exception. Here we see again it's an IO exception. So what? Yeah, that's the IO exception. And now our Christmas carolers, here they were. Okay, so basically we're catching the IO exception, but usually we then either clean up and then we might do some other stuff afterwards. But here we're actually throwing a runtime exception because we're saying, well, we're unable to sing. So there's no point in continuing. And then we could do some cleanup work here in the catch block. And we would also have to repeat it after the catch block, because then if it normally proceeds the computation, then it only executes what's after the catch block, right? So here we decided to put it into a finally block. Now the finally block is very special because it is executed in an abnormal execution case and in addition in the normal execution case. So it's basically always executed. If we catch the exception and do something with it, then the finally block will be executed, which turns off the audio system and then maybe cleans up this file writer, because yeah, it's always better to close the file writer, right? Which could lead again to some exception, but we're going to just handle this and say there was an error. But now the interesting thing is we're actually here throwing a new exception. So we're catching this old, we're throwing a new, and throwing an exception would mean that we jump out of the code right there, right? There's no catch block around this, so, and it's an uncatched exception because it's a runtime exception. Now the question is the finally block still executed? So yeah, let's see what's going to happen. We sing, we do the normal carols, which is a file that exists. So it turns on the audio system, turns off the audio system, and then then it's going to print this exception. So what happened here? It can't find the carols file. So it's actually this file probably doesn't exist, or at least not in this context that it's looking for. So it goes until here where it tries to read it, it throws an exception, then it throws the runtime exception, but before it can really leave, it has to do finally the turn off audio system. And then the exception is thrown, and here it basically interrupts the calling of this. We see here in this main method, line 34, that's where this exception actually goes boom and stops the execution. So the finally block is even executed in case some more exceptions are thrown. So no matter what we do here in this try and catch block, the finally will always be executed. And then we can always clean up the mess that needs cleaning up.
May your Christmas coding be robust and bright, with try-catch blocks and finally shining in the light. May your exceptions handled be or left to fly. Happy holidays and code with joy for you and I.